Welcome to this AQA GCSE Design and Technology exam paper walkthrough for June 2025. Now each exam paper is divided into three sections. Section A, Core Technical Principles, Section B, Specialist Technical Principles, and Section C, Designing and Making Principles. Topic references in this video correlate to the AQA specification. Now some subject textbooks may not use the same codes, but the topic names should be the same. If accessing digital copies of textbooks, pressing Ctrl F can help you search for a keyword or title. For this paper, you must have normal writing and drawing instruments. I would recommend you take a pencil or two. Make sure you have a sharpener, an eraser, a ruler. Don't forget your calculator because there will be a maths element in the paper. And you also need a protractor as well. Use black ink or black ballpoint pen to write your answers and use a pencil only for drawing. Okay, so make sure you use a pencil for your drawing. Do not use a pencil to answer any of the other questions. Fill in the boxes at the top of this page, you know that. Try and answer all of the questions as best as possible, and you must answer the questions in the space provided. Throughout this video, you will see the answers appear on the left of the screen in a yellow box, and on the right hand side of the screen in a blue box, you will get the subject content. Now, Section A will always begin with 10 multiple choice questions. Please ensure you fill in each lozenge using the correct method as shown. Now, number 1, products designed to be more efficient are developed by, and the answer to this is B, continuous improvement. Now, if you are unsure of the content of question 1, you need to revise 3.1.1, new and emerging technologies, specifically environment. Now, question 2, which one of the following is part of inclusive design? And the answer to that is A, design for disabilities. Question 3, which energy source is finite? The answer to that is B, oil. Question 4, a fusible material is commonly described as one that D, melts when heat is applied. Question 5, identify the correct definition of a modern material, and that is B, a material produced through a new or improved production technique. Question 6, part A moves 20 millimeters to the right. The distances between the fixed pivot and the moving pivots are the same. How far and in what direction does part B move? Now the answer to this is B, it moves 20 millimeters to the left. If you are unsure about the content of number 6, please look at mechanical devices, changing magnitude and direction of force. Question 7. New products are developed to satisfy customer needs and wants in response to, and that's C, market pull. If you are unsure of the content of question 7, please look at new and emerging technologies with specific attention to people. Question 8. Which one of the following is a ferrous metal? And that is B, iron. Question 9. Design focused on a fashion is influenced by B, culture. Question 10. Which one of the following is a thermoforming polymer? And the answer is B, high impact polystyrene, also known as HIPS. Moving on to question 11, a 4 marker. Describe briefly the two material properties below. So first we have hardness. A hard material is hard or difficult to scratch or dent. It's hard to cut or abrade or wear away. Can cut a softer material, for example diamond can cut other materials. And a hard material is one that can withstand an impact if something is dropped on its surface. Now, if a product has the material properties of being strong, it has the ability of a material to withstand a force without breaking, a force without losing stability, and some responses may be linked to strength in resistance to tensile, compressive, shear torsion, and bending forces. Now, as you can see, we can accept all other valid responses, and if you are unsure about the content of question 11, please look up Material Properties 3.1.6. Question 11. Explain why some people are opposed to the use of nuclear power to provide energy. Now below are some possible answers, and we are allowed to accept all other valid responses. So, nuclear power is expensive to build and will cost the taxpayer a lot of money. Radiation is dangerous to all life if there is a leak. People are worried about long-term exposure to radiation and the impact on health and well-being. It's a potential terrorist target. Now, nuclear power plants are an environmental disaster if something goes wrong, for example, Fukushima and the tsunami. If there is a leak or disaster, it can make large areas uninhabitable for hundreds of years. There are issues in dealing with nuclear waste, and the decommissioning of nuclear power plants at the end of service is also an issue. So to get the full marks there, you need detailed reasons clearly linked to opposition to the use of nuclear power for meeting energy demands. Question 13, describe the characteristics of a material with elastic properties. Now you could say a material with elastic properties can stretch. It can change shape under force. It can return to its original shape or length. A material with elastic properties can stretch under force, but when the force is removed, it returns to its original shape or length. You would get 2 marks for that. And lastly, a material deforms and returns to original shape. So extended answers get 2 marks, or you could have a series of 1-mark questions for the full 2 marks. Question 14 marks the beginning of section B, specialist technical principles. Now 14.1 is asking for one example of a standard component. Commercial products often make use of standard components in their assembly. This is taken from 3.2.5, using and working with materials. Now, depending on the subject specialism within your school, you could have a number of examples from papers and boards, timber, metal, polymer or textile-based materials, and lastly, electronic and mechanical systems. So pause the video and make some notes. Now, 14.2 is asking you to describe 2 advantages to the manufacturer of using standard components. Now, you can have any number of these bullet points and all other valid responses will be credited. Standard components can be used across a range of different products, reducing the number of different components the manufacturer needs to buy. Point 2, the manufacturer does not have to set up their own equipment to manufacture a wide variety of components to assemble their products. Point 3, it increases the speed of production. Point 4, buying in standard components from other manufacturers can be more cost effective. For example, the economies of scale and buying in bulk. The manufacturer knows that when buying from a reputable source, the components are made by a specialist producer and quality assured before arrival in their factory. Next point, a standard component can be easily replaced with another if it is broken. And lastly, the use of standard components allows the manufacturer to sell their products flat packed or knocked down, and assembling them themselves saves them money and allows them to sell their products more cheaply, as the customer will carry out the assembly process. Now, to get 3 or 4 marks, you need 2 correct simple points of description or 1 point explained in detail. Now, moving on to question 15, there will always be an element of maths and science, around 15 to 20% per paper. Now, number 15 is asking, a company mass produces a product at the rate of 22,000 items a day. In the holidays, this reduces to 4,500 items per day. Calculate how much production has fallen as a percentage. Give your answer to the nearest whole percent and show your working to get the 4 marks. Now, although it says show your working, if no working is shown but the correct answer of 80% is arrived, then you will get the full 4 marks. So pause the screen and look at where you will get those 4 individual marks. And there are 2 alternative methods shown on screen. Now, if you're unsure how to work out ratios, fractions or percentages, this is 7.1, links to maths in the subject specification. Question 16, when selecting materials or components, the aesthetics and their source need to be considered by a designer. 16.1 is asking you to explain why a designer would consider aesthetics when selecting a material or component. And you need to give an example in your answer for those 3 marks. Now, this is taken from 3.2.1, selection of materials or components based on their aesthetic qualities. To get the full 3 marks, you need to have a detailed explanation and aesthetically related example considered in the selection and or use of a material or component. So the guidance provided is illustrative and not exhaustive. So if you say something outside of these bullet points that is worthy, you will also get credited those marks. So bullet point 1, can a brightly colored finish be applied to enhance appearance? So for example, can the material be stained or painted? Number 2, Does the material look good so people want to buy it? Number 3, can the material be finished to give a high quality surface decoration? For example, can it be anodized, screen printed, embossed or varnished? Number 4, where a material may be difficult to finish well, this could be reason enough to reject it. For example, timber marked with interlocking grain or knots. Steel rusts when placed in an environment with moisture and air, for example. Bullet point 5, can a finish be applied to enhance its looks? For example, can fabric be dyed? And lastly, can the material be made to look good so that it will encourage customers to buy it in a product? Moving on to 16.2, explain why a designer would need to consider the source of a material or component. So where does the material come from? Now, to get 3 marks, you need a detailed consideration and sourcing related example considered in the selection and or use of a material or component. So here are some possible answers. We are allowed to accept all other valid responses beyond these bullet points shown. Is the material easy to source? If it's not easy to access, it will make production and deadlines difficult to meet. Can the material be sourced in sufficient quantity for the scale of production? For example, possible future challenges to lithium supply for batteries for electric vehicles. Does the sourcing of the material have a negative impact on the environment? For example, pollution, deforestation. Designers may not want to use materials that might not appeal to potential customers. If sourcing is expensive due to extraction costs from mining, designers may look for a cheaper, cost-viable alternative material. Now we have a social responsibility as designers. Does material sourcing make use of cheap labor with poor infrastructure to support workers and their families? For example, do they have underage workers, poor medical health care, long working hours? There have been many instances of such issues being brought to the public attention in the media. We also have to consider fair trade materials. And ethics. Does the material sourcing harm living creatures? And lastly, there needs to be a consideration of local supply versus global footprint and carbon footprint. So these are the possible answers to explain why a designer would need to consider the source of a material or component when designing a product. Moving on to 17, another 3 marker. Explain why we need to allow for waste when making a prototype. Now, to get the full 3 marks, you need a detailed understanding of waste allowance when making prototypes and products. So when you are developing a prototype, the prototype needs extra waste for tweaks and modifications, making parts and components a bit bigger and longer so you can cut down and modify if required. You can't easily add material. So when developing a prototype, your measurements might not be exact, so you need to allow for waste. And lastly, it allows for trial and error at the prototype stage. Now, waste is produced when cutting out, so all cutting out should be carried out on the waste side of any marked outline, datum or edge to make sure we do not cut the prototype or part too small. And some materials have a surface pattern such as fabrics or grain in woods. And cutting out needs to allow for pattern to repeat or grain alignment to ensure there is no mismatch. And lastly, allowing for waste. Where a blade or saw is being used, allowance needs to be given to blade thickness. Some materials need a greater allowance for waste. For example, timber-based materials where after cutting, additional finishing, for example, sanding or planing, may be required. The use of templates and stencils allow material to be used within tolerances to maximize how many parts are cut from a piece of material. And lastly, seam allowance in textiles or additional material to allow for turns and fabrication, for example, in stitching seams. Question 18. The products and components shown in Table 1 use materials that are modified to make them suitable for specific purposes. So looking at Table 1, you have a polymer window frame, solid wood dining furniture, metal bike hub, a printed circuit board, a fabric pop-up tent, and a paper and board takeaway food packaging. So you are expected to choose one product or component and answer the questions below. So you need to identify which one of those you have chosen. So my chosen product or component is, and you would write the specific one you've selected. And 18.1 for 1 mark, you need a specific main material used. So if you chose the polymer window frame, you could have UPVC, PVC, rigid PVC, polycarbonate and acrylic in substitute for glass. If you pick the solid wood dining furniture, you could have mahogany, Meranti, pine, oak and teak. If you chose the metal bike hub, you could write aluminium, aluminium alloy, or aluminium magnesium alloy or steel. If you picked PCB, you could have written copper, paper or fiberglass. And if you picked the fabric pop-up tent, you could have examples such as nylon, polyester, polyester or cotton mix, or polypropylene. And lastly, if you chose paper and board takeaway food packaging, you could write card, carton board, cardboard, corrugated card, or waxed card. Now 18.2 is a continuation from 18.1, so you have to stick with the product that you selected for 18.1. Name one modification technique used on the material in your chosen product. So for the polymer window frame, you could add a stabilizer, you can add fillers, you can add pigments or spray paint. If you pick solid wood dining furniture, you could have air or natural seasoning, kiln seasoning, laminating, seasoning, staining, wax, varnish or another suitable finish, steam bending and tannalizing. We are not allowed to accept sanding, carving or wood turning. If you pick the metal bike hub, you could have anodizing, chrome plating, electroplating, galvanizing and painting. If you pick the PCP, you could have the addition of a photosensitive layer, making the surface polymer light sensitive. You could have etching, lamination and varnishing. If you pick the fabric pop-up tent as your example, you could have added dyeing or flame retardants or stain resistant finish or silicone coating / sunscreen. And lastly, waterproofing, the surface treatment or waxing. Paper and board takeaway food packaging, you could have additives to prevent moisture transfer, encapsulation, impregnation of card, lamination or foil lining, printing or waxing. Now we are able to accept all other valid responses, and that is one modification technique used on the materials chosen in your product from 18.1. Now 18.3 is asking, why does the material need modifying to make a more effective product? To get the full 2 marks, you need a correct point explained in detail, possibly using a specific example. So if you chose polymer window frame, it would stop the polymer from yellowing and becoming brittle and cracked from UV and infrared light. The solid wood dining furniture would stop the wood from twisting and warping as it dries out in a centrally heated home. And it would improve the durability for outdoor use, for example, tannalizing. If you are unsure of any of this content, you need to look up 3.2.5, using and working with materials, specifically the modification of properties for specific purposes. For the metal bike hub, you would get improved aesthetics to make the aluminium surface of the wheel more attractive or brightly colored. Hardening to stop rain, salt impurities on the road etching the surface of the wheel axle away. For the PCP, it allows a circuit diagram to be developed on the surface of the PCB board. It allows unwanted copper between the individual PCB tracks can be etched away to isolate different areas of the board. Varnishing to protect from oxidization. Tin plate, tinning contact areas for good soldered joints. Now, if you chose the fabric pop-up tent, you would modify the material to make a more effective product by reducing the flammability. Also, some synthetic materials give off toxic fumes that may affect breathing and lead to choking in a fire. Waterproofing to stop the tent from leaking. Silicone sunscreen coating to stop children getting sunburnt from UV rays. And if you picked paper and board takeaway food packaging, it stops the food juices from leaking out and staining clothing and or surfaces. Heat retention also keeps food warm. Now you can see this pattern here. We are able to accept all other valid responses. Now question 19 is an 8 marker based on scales of production from 3.2.7. The question is as follows. Products are made using different scales of production. We have batch production, continuous production, mass production, and prototypes or one-offs. You need to analyze and evaluate the different scales of production a manufacturer can use. you need to give examples of products in your answer for those 8 marks. You are expected to discuss each 4 of those bullet points, the pros and the cons, and the overall evaluation. So to get those 8 marks, you need a detailed analysis and evaluation of different scales of production available for use by a manufacturer, and you need relevant, correct examples given to clarify a response. So here's some indicative content. A response with no product examples can only be awarded a maximum of 6 marks. So if you know the scales of production with no examples, you can only get a maximum of 6 marks. If you only talk about one production scale, it does not answer the question. However, if you have a detailed response of one production scale with an example, you may access the 3 or 4 mark band. Now, the following guidance is illustrative and not exhaustive, and we are allowed to credit any worthy points made in support of the band descriptors to the left. Candidates should discuss the following scales of production. So you have prototype production, also known as one-off, batch production, mass production, and continuous production. So for prototype or one-off production, I would recommend pausing the screen and making notes. You have to include the key points, so an understanding of this method of production, its advantages and disadvantages. So at the bottom there, please note, you may find one-off or bespoke production exemplified as part of a car manufacturer, where integrated manufacture allows cars to be made to personalized customer choices. For example, the color and the trim and so on. For batch production, we have the key points, advantages and disadvantages. So please pause the screen and make some notes. Now it says to please note to be aware of references to batches of components being used in the mass manufacture of a product. So some key points here are a set number of products are made at one time. The advantages of this are good system for making small quantities of identical products, for example, F1 car manufacture. And the disadvantages are when machinery is used, it will need to be stopped to reconfigure for a new task or activity. And this is also known as downtime. So please pause this video and make some additional notes, ensuring that you've got those examples as well in your notes. For mass production, we have many key points, advantages and disadvantages. Just looking at the top bullet points. So mass production produces large numbers of identical products. It's good for manufacturing large quantities over a long time. For example, some vehicles, drinks cans. But the disadvantages are the initial setup cost for machinery and equipment is time consuming and expensive. So pause the video and make some additional notes, ensuring that you write some examples too. So for continuous production, we have the key points, advantages and disadvantages. Looking at the top bullet points now, lots and lots of identical products are made without stopping. So for example, is the process of materials into stock forms. The advantages of this are very limited workforce required, and it leads to less time or loss for comfort breaks, illness and holidays. But the disadvantages here are it's a very high equipment cost at initial setup, and production time is lost for initial setup too. Question 20 marks the beginning of section C, designing and making principles. Production aids are used in the manufacture of products. Explain how or why each of the following production aids is used. For 4 marks, jigs. Now jigs help with repetition and consistency. You may have used those when undertaking your NEA. They help with accuracy, for example, drilling, punching a series of holes in exact places in a piece of material. Jigs can be used to avoid measuring and marking out loads of identical parts. Jigs are used to save time when manufacturing lots of similar parts, for example, batch production. Jigs are reusable, so once they are made, they can be used to make parts at different times. And a jig is a metal device attached to sewing machinery which adds part of a garment, such as a pocket, in place while the machine, the CNC, sews it into position. A jig is used to ensure the process can be repeated accurately and to a high quality. Pockets on jeans are a good example here. Now the next production aid are patterns and templates. Now patterns and templates are used to improve repetitive marking out accuracy. Patterns and templates are a marking out tool. They can help with the nesting and orientation, for example, following the grain lines of parts on a piece of metal or fabric. Patterns and templates can help reduce material waste and ensure it is used more efficiently. Patterns are used to trace outlines onto fabric, so cutting out prior to sewing can take place. In textiles, patterns can help plan for effective material use, where a repeated pattern or design on a fabric needs to be considered. Templates are shapes that are drawn around to replicate the same image of a drawing multiple times on a piece of material. And in textiles, patterns are the shapes of pieces of a product which are made from paper or card. The patterns can be pinned to fabric before cutting out and sewing together, or drawn around before cutting out and sewing together. And we are able to accept all other valid responses. Question 21, analyze the picture in figure 1 and the specification below. So the specification of this exercise bike has a variety of exercise programs. It's internet ready. It has a robust design. It has customer care support. It has an ergonomic design, and it has safety features. Evaluate the exercise bike in terms of satisfying the needs and wants of the user for 4 marks. So to get those 4 marks, you need a detailed evaluation of how this exercise bike satisfies the needs and wants of the user. So here's some indicative content. So when it comes to safety, it has a stable design with rubber feet that can't slip on the floor. It improves physical fitness and well-being. There's a variety of different training options to stop the user from becoming bored. For example, there's a mountain mode or sprint mode. It has adjustable seat and handlebars for user comfort. It has internet compatible to engage with a real personal trainer. You can exercise in the safety of your own home. It has interactive options to exercise online. And it has ease of assembly, so it can be put together after purchase by the user. Ease of disassembly, folding, collapsing for storage, and we are allowed to accept all other valid responses. Now 21.2 is asking for the use of anthropometrics and ergonomics. So when it comes to anthropometrics, look for references to human sizes, dimensions, and not the human body. So when it comes to anthropometrics and that particular exercise bike, it's there to ensure that all features are designed to suit the maximum possible numbers of users. For example, the 5th to the 95th percentile. It has hand grips and pedals that can be adjusted to suit different sized feet. It has appropriate distance of the screen and controls depending on arm length, so they are easy to reach. The buttons on the control panel can be easily pressed with one finger. When it comes to ergonomics, we are looking for references to how the exercise fits and works with the human user. It has an adjustable features. For example, the seat adjusts to suit different users. The display has information and it's very well presented and clearly visible to read. It has a padded seat so your bum does not get sore. It has thermoforming polymers or foam hand grips for comfort so your hands do not slip. Your toe clips so your feet cannot slip off the pedals. And again, we are able to accept all other valid responses. 21.3 is looking for innovation in the design of that exercise bike. So it's interactive features so you can train with others, including compete. It has interactive features that allow the user to get advice and encouragement from other users. Modern materials like carbon fiber to increase strength and durability without increasing the weight of the product. Now this is important if it must be moved around the home or storing away. Now this exercise bike is internet ready. This means you can access different programs and updates to prevent the bike from becoming technologically obsolete. And it has additional apps, for example, cardiac monitor to measure heart rate, etc. Candidates may evaluate by suggesting innovative features that are not necessarily present in that picture. Devices to help the user cool down. It plays music and links to your phone. A drinks holder to hold a cup and stay hydrated. It links to a Fitbit. Watch performance data. And again, we are allowed to accept all other valid responses. Question 22. Figure 2 shows a decorative surface of a product based on a green rectangle with 6 identical blue squares. All dimensions are shown in millimeters. Now, using the drawing and the dimensions provided, calculate the ratio between the 2 different colors used to create the decorative surface effect. Give your answer in the simplest form and you must show your working. Now, this is for 6 marks. So pause the screen and on the left, you'll see the marks in the left column and you need to subtract one area of color from the other. So you must show your working out for this question. The ratio is 1 to 2 or 2 to 1. And to break those 6 marks down, you need to work out the total panel size, the area of one blue panel area, the areas of the 6 blue panels, the proportions, and the ratio before simplifying it down. Question 23.1 for 4 marks. Figure 3 shows a component partially completed in third angle orthographic projection with an accompanying 3D isometric drawing. Complete the orthographic drawing by adding the correct right-hand side view for the component. So if you look at figure 3, you can see the plan view, the front view, and the isometric projection, and you are expected to show the right-hand side view. Now it is shown in red. You will get 1 mark for the basic correct shape, so the L shape. You will get 1 mark for the L shape elevation drawn the correct way round, including the solid vertical line indicating the angled face. You'd get 1 mark to show the 2 hidden detailed lines for the hole, not extending outside the L shape. And you'd get the 4th mark for showing the center line of the hole extended outside the drawing. Now the subject content for this is 3.3.5, communication of design ideas, specifically third angle orthographic projection. Now the second part to 23, study the table in figure 4. Which symbol is used to correctly indicate a third angle orthographic drawing? Put 1 tick next to the correct symbol in the column provided for 1 mark, and the answer to this is D. Now question 24, a manufacturer wants to produce 6 weather vanes similar to the one in figure 5. They have 2 manufacturing methods, 1 skilled worker and a team of 5 workers working together to make each weather vane. 24.1, method 1 is 1 worker only making 6 weather vanes. So study table 2 and it shows the costs of making 1 weather vane by this method. So the tools, equipments and material costs are £5. Labour costs per hour are 22 per hour. And the production time for 1 weather vane are 4 hours. Calculate how much it would cost to make 6 weather vanes using this method, and you need to show your working for 2 marks. So we need to award full marks if no working shown, but the answer is correct. And you get 1 mark for crediting any calculation from the 2 indicated below. So the total cost of 1 weather vane is 22 times 4 plus 5, that's £93, or the total cost of 6 weather vanes as 93 times 6, so 558. The fully correct answer only is 558, and if you were to just write that number, you would get the full marks. Now 24.2 is asking you to study method 2, 5 workers working as a team to make all 6 weather vanes. Study table 3 showing the cost of making 1 weather vane using method 2. Now the tools, equipments, material costs are £5. The labour cost per worker is 22 per hour, and the production time for 1 weather vane is gone down to 0.5 hours. Calculate how much it would cost to make 6 weather vanes using method 2 and show your working. Even though it says show your working, it says award full marks, even if no working shown, but the answer is correct. So to get the full 4 marks, you could write £360 as the correct answer, but pause the screen and work out how you would get the additional marks to show your working out. Now 24.3, which of the 2 methods is the more cost effective for the manufacturer? Explain your answers for 2 marks. So 1 mark for correctly identify that method 2, 5 workers or table 3. 1 mark for any valid explanation point. So please note the wrong method but correct reason gets 1 mark. So we have lower total labour costs, increased productivity, reduced production time, workers are more productive on a special task, but we are not allowed to accept cheaper or quicker unless it's qualified. We are able to accept all other valid responses for those 2 marks. Question 25. Prior to making, materials and components are selected for their product function, their cost, and their availability. Explain why each factor needs to be considered before choosing a material or component for use. Now this is taken from 3.3.7, the selection of materials and components. So picking a material or component for the product function means what is the material required to do? Is it supposed to support its own weight or the weight of something else? What conditions does it have to work under? For example, does it need to withstand any wear and tear? What specific properties does the material or component need? Should it be light or heavy? Will it be fit for purpose? For example, simulate or just mock up a non-working product or do something. Will the material be easy to work with to create the prototype? And can the material be finished to the correct quality for the prototype? Now, when it comes to cost, if the prototype is a mock-up, the designer will not want to spend a lot on materials. If a lot of material or lots of components are required, can they be bought in bulk to reduce manufacturing costs? What quality of materials can be used? For example, high quality expensive materials are not usually needed for a mock-up or a prototype. Are materials easy to work with, meaning there are no additional costs needing expensive tools or equipment to be factored in to make the prototype? And the use of recycled or upcycled materials for the prototype would be desirable to get the prototype or fabrication costs down. Now, when it comes to availability, can the material be easily sourced to quickly make a mock-up or prototype? Valuable time can be wasted ordering and waiting for materials or components to arrive to make a prototype or mock-up. Are they in stock with a retailer and quick to deliver? Are the materials and components available in stock forms and sizes? Selecting materials and components that are readily available will fit in with development in time frames of projects and deadlines. Now, as you can see, we can accept all other valid responses. Question 26 is asking you to explain how increasing carbon dioxide levels in the atmosphere impact on the design and manufacture of products. Now, that's for 3 marks. To get those 3 marks, a detailed explanation of how increasing carbon dioxide levels in the atmosphere impact on the design and manufacture of products. Some possible examples are highlighted here. First one being by purchasing goods using materials from sustainable sources such as FSC timber, supplies can be replenished, removing carbon dioxide from the environment, and ecosystems and places people and life on Earth inhabit can be preserved for future generations. Point 2, reducing CO2 levels, carbon footprint, by using fewer materials or sourcing materials closer to home. Point 3, designing products that can be repaired, upgraded and maintained. Point 4, designer and or manufacturer needs to be considerate of the 6 R's. The next point, designing products consuming less power or energy, manufacturing using renewable energy, fewer fossil fuels, and lastly, society and consumers as members are increasingly aware of the impact that their choices and demand for products can have on the world in which we live. Consequences may choose to upgrade their mobile phones or car less frequently. They may choose to upcycle clothing. This avoids extreme consumption of resources, particularly primary processing and extraction of raw materials to make new products. And lastly, question 27 for 6 marks. Explain why designers should investigate and research existing products before starting to design new products. Now, to get the full 6 marks, you need a detailed explanation as to why designers must research and investigate existing products. Clear comment and understanding of why this is needed before starting to design new products. Now, this is taken from 3.3.1, carrying out investigations in order to identify problems and needs. Now, you will get full marks for responses with a single well-developed response. So let's look at some valid responses. So explain why designers should investigate and research existing products before starting to develop new products. We do this to identify good and bad points in existing designs and to avoid building in those bad points and features. We do this to assess the commercial viability of your ideas. We do this to carry out investigations to identify problems with existing products. Research and investigation inform prototypes. We do this to find out what materials are used to make existing products, to find out assembly and construction processes, to identify a price for existing products to ensure they and new products are competitively priced. We do this to develop an understanding of competitors' design and consider how function, operation, and use can be improved. We do this to find out what intended users think of existing products and what they would look for in a new and improved product. And we do this to find out if existing products meet the needs and wants of their intended users and target market. We also do this to avoid infringement on someone else's intellectual property, so to avoid copying them. The use of examples may help to further explain and clarify responses and should be rewarded if relevant. And lastly, we are allowed to accept all other valid responses.